you for attending this talk, which is called Agile Testing, a Shift Left Approach. We presented at the Leeds Digital Festival just under 2 years ago now on the theory of shift left testing. And at that time, I asked the audience, yes, it was an audience in a pub, remember the good old days when you could do that, who understood the term shift left. And I think out of 30 odd people, 2 people put their hands up. I'm hoping now that the term is more prominent, more widespread and more understood. But if you are still in the dark about what shift left means, sit tight and we're going to talk about it this afternoon. So before we start, for those who are unfamiliar, we are Answer Digital and we are a 20-year-old employee-owned digital consultancy based in Leeds City Centre. There's 80 people in our team and we deliver digital change projects for our customers in finance, health and retail sectors. We are extremely proud of our people and the work they do, but more so how we do our work. And that sets the context for today's presentation. Okay, I'd like to introduce 2 guys. Well, first of all, introduce myself, Richard Walker. I am the Answer Managing Principal and I head up the test team. Helping me out today, I have 2 of the lead testers, Joe Batt and Rob Gaskin. And they're going to help me out today. Okay, so what we're going to cover. So first of all, I'm going to cover a bit of background, basically a summary of our last presentation in terms of what do we understand by shift left testing? What are the benefits of shift left testing and what's driving the prominence of it? Why is it beneficial for businesses to adopt this approach? Then the guys are going to take over and show you over the last 2 years how we, Answer Digital, have adopted a shift left approach to our projects for our customers. The types of testing that we use, the approaches, the tools and the technologies are going to give you a good overview of functional and non-functional shift left testing. We're going to then finish with a little section around the business, because this is not just a dev team activity to shift left. We need the business on board. We need them to have to come with us on this journey. And finally, we're going to have a questions and discussions section. And to do that, today we are using Slido. So you can go to slido.com, put the code in and ask questions as we're going along, and then we'll attempt to answer them at the end of the presentation. Okay. Right. So first of all, what does shift left mean to us? Well, fundamentally, shifting left is the identification and ideally the prevention of defects earlier in the delivery cycle. We're going to try and get away from I go into organizations and I see test teams that are very reactive. They're waiting to see what comes out of the development process to spring into life and do their testing. We want to turn that on its head. We want to get the test teams involved early in the process so that they're involved in designing QA processes that are going to help us identify and prevent the defects early in the process. And we're going to talk about some ways that we do that later on. In terms of a test strategy, again, I see organizations with very thorough test strategies, with test phases, how they're going to do them, when they're going to do them, and that's all great. But our test strategy needs to be more flexible than that if we're shifting left. A shift left test strategy has to have a #1 goal of what's the earliest opportunity that we can start testing. That is the thing that we want to look at. And Rob is going to talk through a case study where we're performance testing against APIs that are written in sprint 1. You know, we're not waiting for later down the line. So let's look for the earliest opportunity and let's shift left. So what's driving the prominence of shift left? What's the benefits? What's the business case for trying to adopt this approach? Well, if we get the testers involved earlier on and collaborating with the developers on a daily basis, sat with the developers, you know, working together, and on top of that, you've got the product owner who's representing the users, and they've got the shift left mentality as well. Add to that the UX designers who are bringing the stories to life with their wireframes that hopefully have been tested with the users. The combination of those 4 in a 4 amigos session, for example, is powerful. It increases the communication and the collaboration amongst the team, and that can only lead to successful projects. If we're successful in this shift left approach and the results are what I am preaching now, then we will save costs through fixing defects early and prevention of defects. There's the famous graph which shows the exponential increase of costs of finding and resolving a defect at various stages of the delivery cycle. So obviously small cost if the developer and tester can find that together, even before it's been promoted to test. As opposed to finding a performance defect in production, which could be catastrophic and probably result in a rewrite. In terms of the tools and the frameworks we're using here, the automation frameworks, automation is key, and the guys are going to talk about automation. That's key in being able to release as often as we can. Multiple times daily if we want, because we've got that real-time feedback on the health of any candidate release. We're going to be instantly fed back to tell us whether we've introduced any regression issues. And ultimately, as a business, that will save time, money, and organizational reputation. Nobody wants to put an app or a system out there that gets pulled immediately due to a quality issue. We need to make sure that the quality is high on all our releases, and that is at the heart of shift left. Okay, I'm now going to hand over to Joe, who's going to talk you through some aspects of our shift left test strategy. Over to you, Joe.
Cheers, Rich. So as Rich just said, I think one of the most important ways you can shift left is through the adoption of test automation. But it's not simply just implementing test automation, it's about adopting a successful test automation strategy. And that's what I'm going to go through. I think most people have heard of unit testing and UI testing. End-to-end testing, normally using Selenium. However, a successful strategy is built using a multi-layered test automation approach. As you see there, we've got quite a famous diagram called the automation pyramid, and that's a concept that we use for writing a successful automation strategy. It shows the frequency in which tests should appear in your automation solution. Towards the top, tests tend to be quite complex to write, brittle, expensive to maintain and create, and slower to execute. As you get towards the bottom, they are easier to maintain, quicker to execute, give instant feedback. So what does this all mean? Go back, Rich, please. All right. So what does this all mean? What are we actually talking about when we look at the automation pyramid? What are we actually testing at each layer? So unit tests, these tend to be written by the developers. These are your foundations, obviously testing individual units. Now, people tend to have different definitions of what constitutes a unit. I decide on a definition as a team. The expectation at Answer is that the unit tests go up with the development code and they're reviewed as one pull request. Your integration tests, these are your API tests. Generally, we cover payload validation, HTTP response codes, query params, any business logic, and we also hit the service with any users who's going to be exposed to that service as well to make sure that they get the correct information. To support this kind of testing, the integration testing, we obviously implement a catalogue of test data which the services expose. Our component UI tests, so these are testing an individual part of the system in silos, such as an edit address component. At this level, we're checking field level entries, validation, error messages, making sure that the front end handles the expected behavior of the API. We use mock services to do this, so everything can be run in silo away from the actual full implementation. We work very, very closely with the developers around when we're coming to do this, because we need to make sure that a component and a service are testable and can be published in silo. Finally, when we get up to the top, we're talking about the end-to-end tests. We cover user flows, for example, like a login, change address, and a logout. These are executed on the fully deployed application, and we perform any multi-browser automated visual testing at this stage to make sure that the application looks and behaves as expected. And then finally, we've got manual tests. So these are tests which have a low automation ROI, or something like usability testing, which obviously you can't automate fully. There is an anti-pattern to this, so we've seen this from other companies, and it's called the ice cream cone. We tend to see this when a company starts to implement a strategy, and it's easy to fall into this because the Selenium tests, the end-to-end tests, are really easy to write because it can be written without any interaction with the developers and the testers, in theory. what you'll do if you do this, so is you'll find that the tests are really costly to create and maintain. The suite is really slow to execute, and the tests become more brittle, meaning there's low confidence in releases, leading to more manual checks, which you'll see there is the actual ice cream on top of the cone. You'll just be finding issues. Also, with this model, defects are caught later. As we just discussed, the end-to-end tests are run on a fully published application. So you're already introducing defects into higher environments before you find them potentially. Okay. So just to recap, why is it important that we look at testing from multiple layers? So we get an increased code quality and reduced costs. So issues are identified and fixed early as the application is tested on every build and release. Rob's going to talk about how we do that in the pipelines. This is the true value of shift left, actually stopping code being promoted to environments and cutting down the number of defects that are leaked into the higher environments. We get an increased automation return on investment. So obviously the lower down the pyramid, the tests are quicker to script, execute, and less brittle, so they give you more confidence. Again, release with confidence. So as each level is tested on demand, reports are generated and shared with stakeholders. We build trust in the shift left process and our releases. We increase speed to market. So if a change has been implemented for a particular service or component, then we can target regression to just those services or components. We shouldn't need to run a full-scale regression over everything, because the way it's been written, it's all modularized. And we reduce the execution time down, so we're not having a load of complex tests that are really slow to write, and we just basically increase test coverage as well. Okay. So shifting left on UI testing. So how do we actually do this? So I'm going to talk through some of the practices that we perform at ANSA to facilitate us shifting left on all these layers. So traditionally, automated UI tests come after development. I think people will be quite aware that a solution gets delivered, then you'll see testers opening up the dev tools and going through and finding CSS and XPaths, etc. But by the time you've actually run your tests, issues could already be released, obviously increasing costs and delivery time. To shift left on the UI test, we go through our wireframes and we attach comments to them, which specify custom HTML attributes. We'll show you later. By doing this, it means that the testers are also specifying how the DOM structure should be, which means then the UI test scripting can happen in parallel with the development code, because we just create the page update model and implement the steps based on the specified custom attributes. This leads to obviously tests being executed as early as possible in the pipeline. Because testers and developers work in parallel, generally we try to meet in the middle and push everything as one pull request. So they're just running the build or running the release pipeline when they're needed. Cheers. So this is just a quick run through of actually how we do it in terms of the custom HTML attributes. So you'll see here just a generic sort of wireframe that's created for one of our projects, and you'll see all these pink dots. This is where a tester's gone in and specified the attribute for an element that's going to be needed for a UI test. Okay. Then the tester goes away and is able to create the page object model based on these attributes. Okay. And then you can see that developers have actually implemented those attributes, and you can see them in the HTML. So we're not waiting for things to be released before we start actually creating the UI tests. We're able to do those up front and then get them tested early. Okay. So shifting left on the API tests as well. So we work really, really closely with the developers. We need a way to run the services. So whether that's in memory, Kubernetes, or on localhost. We're very, very conscious that when we're developing services and components that we're doing it with testability in mind, so we can spin them up in silo. We also create a data catalog for the services to use when they are in test mode, so they can expose the data to the clients. We also ask developers to add the API contract onto the ticket before the development work has started. That should be phase one, really. So it gives us an idea of what they're intending to create and the behavior of the actual service that they're going to create. I'm just going to show you now an example of how we actually, of a user story that we've got in a project, and how we actually break that down into all the multiple layers. So I think everyone's quite familiar with how user stories are written. I don't think we're especially different in doing that. You know, we've got user story, we've got acceptance criteria. If we just go to the next slide. This is where we ask the developers to add the API contract. So you can see here, we've got the endpoint, we've got the methods, we've got the parameters, JSON, the response codes. So we've got all the information for us around the design of the API contract before the development's even started. And then, as we've seen before, we've got the wireframes as well to help us with our UI testing. So the developers have all the information needed, and we have all the information needed to be able to do all this testing, all the development up front. So when we go to actually split down this user story, which is actually a real life example of what we've done, we've got it broken down into API, component, and end-to-end tests. So you can see there that we've got we're covering all the API contracts. So we've got the 200s for different users, all the different payloads that we expect to have. We've got 400s, missing any mandatory fields, 401s and 404s as per the contract. The component test that we're testing field validation messages, building society formats, save or fail of same details does not create a case, and some save of non-UK accounts. And then the E2E, we've got a login, change of bank account details and log out. That test runs on multiple browsers and integrates with an automated visual testing tool to make sure that the screen markup's correct. So we've actually had a look at this. We've ended up with 21 API tests, 9 component tests, and 4 end-to-end tests. Now the 4, it's actually only one end-to-end test, but it runs across all the browsers. Now, what that means is obviously the API tests actually only take around 15 seconds to run. The component tests take 20 seconds, and the end-to-end test takes about a minute. So we're able to fully test this change of bank details really, really quickly, and we can obviously regression test it. So the reporting that comes out of it, it's really easy to miss this. So we need to, obviously, based on test results, give accurate reporting. It allows the developers to investigate issues easy, speeding up fixing times, as Rich said, as we sort of shift left. The HTML reporting that we see as well can also be used as sign-off to clients. So we can start getting them involved in the process and sort of increasing their confidence in what we're doing. So what we see as effective reporting, it should be easy to understand. Now, we tend to use Gherkin syntax here, but even if we're not, I tend to, all the methods should be written in plain English so we know what they're saying and they then can be seen on the reporting. They should have screenshots and stat traces attached for any failures, and they should be published via a push model, which Rob will go through shortly. So there's a couple of examples of what reporting we actually use. We use Alert, Extent, and Mock Awesome, generally speaking. Now there are other tools. There is a report portal which you could deploy in Kubernetes and provide real-time interactive results dashboard and share with the team and client if you so wish to do that. Okay, so we just talked about the automation. I guess I'm going to talk about some of the pitfalls and the best practices, just a bit of a recap. So it's the optimization of tests. So as you actually create all these tests, as we just talked about the ice cream cone, it can become a hindrance to continuous deployment. So you've got to be really, really careful around where you're putting tests and optimizing your tests. So you use an efficient use of weights, removing any implicit wait times, recycling the browser session. So we do that quite often, rather than spinning up a new browser every time. Choosing the correct tools for the job. So we see a lot of times that people default to Selenium, whereas if you thought about what they're used for, potentially Playwright or Cypress might be a better fit. We run the tests in the pipelines. So defects are found earlier. Tests are run on demand and when they need to be. We don't blast the full system with a full regression. We just hit key areas. And you also talk about, do you want to run them on hosted agents versus cloud agents and the performance benefits there? Again, touching on target regression, so you only run the regression for the change that's going in. That's fine. We tests live with the actual code base as well. So many times we've seen that the developers will have one repo, the tests will have one repo, one solution that's completely separate from each other. That's not the best way to do it. You need to have the tests and the development code living together so they never get out of sync. And you need to design the application with testability in mind. So it needs to be well documented. You need to think about the ease of publishing all these services and components in silo. And you need to have effective logging and be able to mock and drive the test data from your actual tests. If you start to do this, you can see that there's going to be multiple production releases, and the shift left enables the deployment of code to production with confidence multiple times without the long traditional UAT and manual regression phases. Okay, so that's it from sort of functional automation side. I'm just going to pass over to Rob now. We'll take you through non-functional and pipelines.
Thanks, Joe. Oh. Can you hear me? Yep, good stuff. So I've just seen a question appear on Slido. So the question is, how does shift left enable CI/CD? And hopefully, I'm gonna be able to answer this question now. So you might have heard of continuous integration, continuous deployment. It's a big buzzword in the IT industry lately, and the core of how that ties to shift left, I believe, lies with continuous integration, because it's the furthest one left. So continuous delivery and continuous deployment more focus on pushing software out, whereas we want to shift that left, and in continuous integration we can do this. We can do the necessary steps as early as possible. So typically, on a very typical continuous integration pipeline, you would have a set of stages that would do certain actions. On a very basic pipeline, you'd have some unit tests, and you'd have some component tests that run as soon as a person pushes their branch of code onto a CI system. So you're not dependent on the deployment. You're testing straight away. You're testing right as soon as I've got something that can be tested in isolation, I'm testing it, and then afterwards, you then once that code's been merged in to get terminology. So as soon as that block of work has been moved on to where all the other developers work off, you straight away deploying it, and then once it's deployed, you can start kicking off your integration tests and your end-to-end tests, which are like your core tests, and then from there on, you can start thinking about continuous delivery. So you can start thinking about pushing deployment. And like Joe was saying earlier, with the test pyramid, at that point, once you go into the delivery side, you can start thinking of doing small amounts of tests, because that's shifted further to the right as opposed to the left, where the left is the core amount of tests. So okay. Why do we do it? Well, I've kind of explained it, gone into a bit of detail already, but one of the core things about this is that you get developers thinking about testing, and that because when they merge in, those tests are being executed. So if something goes wrong, the responsibility may fall on them to fix the code, or it may fall on the tester to fix the test, and that sort of working in collaboration with developers and tests, that's really good, and getting devs to think about test is very important in modern development, I believe. Historically, you may, in the past, I've worked with test suites that have been separated from the development code, and that's a severe risk, because continuous integration means that you're forcing to do your tests, so your tests don't suddenly come out of date when a new code has been pushed out. You get that feedback that yes, something's changed, update your tests, or there's a bug, go fix the code. And it's a very important part, that, because what you don't want lots and lots of legacy test suites. You just want a core set of tests that run in your pipeline, and it's a key part. And of course, because the pipeline is an automated block, an automated function, you do it in tools such as GitLab CI or Azure DevOps, which are tools built for this, basically. And they don't, because you don't need a tester to click a button to execute a test. The tests run automatically in the pipeline, and so you don't need Joe the tester to be in that day. The test will still run without him. And another thing is, as earlier as I was saying, repeating the point again of how the pyramid is built, the test pyramid is built, and because CI/CD, you want to do as much unit component testing as much as you can, and because it's functions of code, blocks of code, that it's like you've forced yourself to shift left because you want to do as much testing there because it's cheap and efficient to do in a pipeline to do that there. Okay. So how do you take that pipeline idea of having your build, having your unit test, and all these things, and how do you get them actually into these GitLab CI, or how do you get it into DevOps? And okay, typically you would use. Can you just go to the next slide, Rich? So typically you'd have a concept called stages. So you don't write a monolithic script, the monolithic deployment script that does everything. That's very hard to keep track of, and you're opening yourself up to a lot of technical debt if you do that. So what these modern tools now use is a concept of stages, and these stages are basically a set of actions that represent a tangible action. So for example, you would build your code, you would test, that would be a separate stage. You'd test your code, that would be a separate stage, and you'd have your unit test, that's a stage, component test, that's a stage. And with some tools you can get clever with it where you can do stuff in parallel. So you can run your unit test and your component test in parallel, so they become the same stage as local tests, but they run as individual jobs. You have your deployment, and you have your integration test and your end-to-end test. And so all of these are like stages and actions of how to build things. And as a tester, you're not typically responsible for everything. This is why you need to work with your developers, because especially with GitLab CI, you will be editing the same file. You will be working together closely with your developers to develop this pipeline, because yes, I'd expect them to do the build, the deployment, the unit test. There's still the case of how do you set up the integration test and end-to-end test, and the responsibility is going to vary based on team. But the general gist is that there's some responsibility on the QA side of things and some responsibility on the developer side of things. And yeah, if you go to the next slide. So here's a big rundown of a GitLab stage. It's getting a bit technical, this, but I'll try and keep it flowing. So you have your stage, which is right, what sequence do I want to run it in? So this is UI test. So this UI test is a stage that runs after everything else. You have your image, so if you've used Selenium in the past, you may have experience with Selenium, the Selenium server side of things. That's basically what this is. It's just a box that can run a test. Here I'm using Playwright, which is a different automation framework, but the gist is that this image has all the dependencies I need ready to go. Then you have, like I was saying earlier, where you might have blocks of code running in a different place in terms of continuous integration. We only want to run this in develop because that's where all the devs are working for. So because this depends on deployment, we need it to be in developed and deployed, and then we can run this test. Then you have the scripts, which is what you're doing, and then you have your artifacts, which is pretty much what you like. So if there's any output of the tests, we can do something with that, which I'll get into next. So reporting is a key part of continuous integration and shifting left, because you need the problem is there is a downside of putting stuff in the pipelines where you don't know exactly what's going on when it's running. You're not watching the tests, so you need that reporting, you need that information to understand what's gone wrong. And there's often the case where you'll end up in a scenario where it'll work on your machine but not on the dev box. So you've got to basically figure out what's going wrong there. Okay, and one final note, it's also very important to tell people that something's gone wrong, because typically I don't spend all my time watching pipelines. I don't think anybody should. So what you need to do is you need to have a mechanism in place that will basically say, right, here's an email. and or in another case, here's a Slack message that will basically inform the development team that something's gone wrong and there's something to look at for either a tester or a developer. Okay, so Richard mentioned it briefly when he was introducing it, but when we talk about shift left, it's often associated with functional testing. I'm now in the case that it's actually applicable for absolutely everything, and hopefully my case study here will give you a good example of why you would shift left on performance testing. Okay, so so a bit of backstory. We started a new project. It was for a company called Prin6, and we started looking at using something called Azure Logic Apps and Azure Functions, and it was all fairly new tech to us, and we got a very basic demo app running using Logic Apps, and it required a little bit of work to just get to a point where it was ready to tell that something was going wrong. And eventually what happened was we started playing around with Postman, and the performance was just getting terrible, and we thought, well, maybe it's just, a developer told me, well, maybe it's just it's cold, that's why it's slow. And I decided, right, this is the point where I need to shift left now. I need to start thinking about, right, let's get some performance tests up and running. Let's get a JMeter script going. And at that point, we were kicking off our tests, ready to go. So we eventually figured out why it was slow. We pinned it down to the Logic apps, so the Azure functions were fine, but the Logic apps were slow, and that meant we now had a target of what we can change. And because we did it so early, integrating with other things was doable at that point. So we tested loads of alternatives. And because we were still in the shift left mindset at that point, we were performance testing all of these alternatives, and we were like, yeah, this is much faster. This is a bit faster, and we came up with a good solution of, right, we've found a good alternative now, and now we can make that diversion. And we made the diversion, and we solved the performance issue very early, as early as possible, because the PM came to me, and he was starting to concern with performance when we saw the front end, but we were already doing the API testing earlier before the front end was finished, so we'd already shifted left, and we were already looking at the problem before the project manager knew why. Okay, so why do you do performance testing? Why would you shift left? Well, the first thing is that people tend to sometimes shuffle things under the rug. Shift left is about being completely honest all of the time and dealing with problems there and then. And well, some of the benefits of shifting left for performance testing is you can figure out how your system works early, and you can figure out what you need to look out in the future if something goes wrong. So you're kind of proactively planning for future problems, because you know what to look at if things start going wrong. And of course, you can make those early diversions. You can make those emergency diversions early. And yeah, so how would you go about doing it? So typically you would create a quick JMeter script that would just basically tell you, use tools and like BlazeMeter, which is an extension which I'll show in a second, which basically will create a JMeter script for you very quickly. I used to be against testing tools that automatically generate stuff, but if you know what you're doing, you can modify that generated code into a format that will be useful for you. And that's an important skill to have. Understanding of how HTTP works. So if you understand how HTTP works, you understand how things point to each other. That's all very useful, because that lets you test your APIs, which lets you shift left. And then understanding all the pieces and parts of your system, letting you test those things in isolation as components. Again, shifting left lets you start talking to things individually and figure out, is this the problem? Is that the problem? And lets you solve those problems earlier. And then, of course, you have to understand what the stats are telling you. So, I mean, it's easy to say, right, this is really slow, but you have to understand, like, if you go into Azure platform, right, this is saying that that's this fast and that's got this much RAM, and you have to understand what those stats mean. Usually, very basically, though, at the start of a project, this can be really basic and could be something like as much as it is just the response time that you're concerned about, because cloud platform solutions often scale properly and have allocated machine stats, so you don't have to worry that so much with cloud platforms. Okay. So this is the BlazeMeter extension. It's a dead easy tool. It's a Chrome extension. You can install it, and basically, if you click the record button and go to a website, what will happen is it will open up a Google. You open up Google, and then it'll save that as a JMeter script. So that's that. So okay, getting the stats from your performance test. Usually dead easy if you shift left, because it at that point it doesn't have to be complicated. So as a JMeter script, if you ever run JMeter on the bash line, you say I want to output a report here, and there you go. And then of course you got your Azure platform stats as well. So security testing is an interesting one, because traditionally, usually most projects go through a pen testing phase, and it usually happens at the end when all the code's written. And I think you don't necessarily have to be a security expert. There's some really good tools, such as static code analyzers, such as Fortify and SonarQube, which will scan your code and will tell you if there's any security flaws. And by doing that earlier in the process, you're shifting left, and thus you're potentially saving your time fixing costly bugs where the pen testers have spotted something. So it lets you potentially spot issues earlier. And then you have dynamic app scanners, which is like stuff like OWASP, which is a similar sort of thing, which will basically scan your code, scan your endpoints, and talk to those endpoints and basically try and break them. And yeah, okay, so that's the goal of security testing, is to shift left as much as you can with much knowledge. I'm no security expert, but I know there is a few things I can do to shift left on that. Let's shift left. So in terms of pipelines, security testing, fine. You can put that in your pipeline as a separate stage. I was talking about earlier. For example, you would put it after your end-to-end test. So you would have a stage called security test, and that would execute the security test. But in terms of performance testing, you have to basically use something called a scheduler, because you don't want to run a performance test against every single commit, and B, you want to control when your tests run as well. So for example, the scheduler allows you to set up a time when the test is run, or you can just click the play button and basically that'll kick off a performance test for you. And if you go back to if you think about the GitLab config file, it's just one step there, and possibly a warm-up step as well. So that's the basics of that, really. So handing back over to Mr. Walker to tidy things up.
Thanks, Rob. Good stuff. Okay, so if your dev teams are shifting left and doing a lot of these testing practices, that's all great. But as I mentioned right at the start of the presentation, if the business are not on board with shifting left, if they don't have a shift left mindset, then there's going to be problems. So I'll give you an example. I worked on a project recently, and we had a product owner who I sat down with, and he was representing a group of users that came in to help the project. I talked to him about testing very early. You know, we had a series of sprints that were going to eventually release an MVP. And I promoted the idea of we want to get away from a 6-month UAT phase, which they have had in the past, to testing every sprint and building up a set of tests that we're going to automate and run every sprint. So by the time we get to the sprint prior to release, we've got good test coverage, good regression coverage, and we're very confident that the functionality is ready for production. He just didn't get that, and the user didn't get that. And the reason they didn't get that is because after sprint 1, we were producing, limited functionality. And for him and the users, they felt that they couldn't test it unless they could do the full end-to-end system, basically their day jobs on the system. So yeah, it was very difficult. subsequent projects, we've had a different product owner who had a different mindset, who did help us validate and test on a sprint by sprint basis, and we didn't have to go through that long UAT phase. So it's really important to get the business on board. They need to have the mindset, and to do that, we can use processes like sprint fit. Is a story fit to go into the sprint? Is the user story defined well? Do we have a set of business acceptance criteria that define what the story needs to be to pass to be ready for production? Does it have a set of test scenarios that support those acceptance criteria? And do we have any sort of wireframes that have been tested with users that can help with the understanding? And 3 Amigos sessions, we actually call them 4 Amigos because we've got the developer, the product owner, the tester, and the UX designer in a session together, going through those 4 different views and creating a shared understanding of what we're going to build even before a line of code is written. We're going to try and prevent people going off down the wrong road. We're going to prevent defects before they've even happened, hopefully. Okay, I think that sums up our talk. We are going to now answer some questions. Hopefully there are some questions. And not being a Slido expert, how do we do it? Rob, you've got the questions.
I do indeed. So the first question after the initial one was, is there still a need for testers now most of their job can be done by developers?
Oh, that's a brilliant question. And I'll take that one. Yes, I mean, looking at this presentation, if you were a manual tester, and I'm sure we will have manual testers in the audience at some point, you might think that this is development, this is technical stuff, and yes, it is. And we have built up a team of technical testers that have the technical skills to be able to write code, to understand code, to create automation frameworks, to do all this good technical stuff. But at the end of the day, this is the point. The testers, the big value the tester brings is through their mindset, thinking differently, thinking about the what-if scenarios. In those 4 Amigos sessions where the developer, I'll have a few developers scowling at me no doubt, are thinking about the happy path and trying to get that working, the tester's thinking about what if. What if this happens? What if we haven't got this information? What happens if this validation fails? So yes, all the technical stuff is in the toolkit of the tester, and it helps them collaborate and work closely with the developer. But I firmly believe the value add the tester brings to this is through their mindset and the way they're thinking about this.
Yeah, just to add on to that from the pipeline perspective, I feel like that's the team's responsibility as well. You say it's very techie side of it, but it's the fact is that the integration test and the end-to-end test live in there as well. So it's kind of like those things are you need both a tester and a developer for both of those things.
Any more questions, Rob?
Yeah, so there's one from Anonymous. They're all from Anonymous. If the test is produced prior to development, is there a risk the wireframes change during development and the tests need to change? I believe that's one for Joe.
There is always that issue, isn't there? But generally, we shouldn't be accepting things into sprints, that have the possibility of change. Obviously, there are things that come up, but because we work quite closely, the developers and testers work very, very closely anyway. We're both aware of the same change, so they could go off, make the change and come back together. They should be making those changes in parallel anyway, because it'll affect both work streams.
Rob, any more?
There's one more. Does shift left implementation differ between BDD and TDD?
Go on, do you want to go?
Do you want me to answer that?
You can do, Rob.
Yeah, my personal opinion is that TDD is actually the pinnacle of shift left, because it's the testers. The testers are driving everything. I don't know what are your guys' thoughts on that?
Yeah, I mean, for me, BDD is becoming. There's a new one called the ATDD, which is acceptance test driven development, which is building on the TDD. I'm basically, obviously, devs. I know that there'll be people here who believe that yes, the unit test should be written, And I'm sort of a big believer in, yes, write the test first. And that's where we're trying to get to, where we write in at least the scenarios first, and then they fail and write the code to make the test pass as well. The reason we use the BDD is around the Gherkin syntax, and you're actually describing the behavior. The TDD stuff can be then used for unit testing as well, or API testing.
Cool. Any more questions, Rob?
No, that was the very last one.
Right. Well, thank you all for attending. And if you want to contact us on anything you've heard today, if you're interested in anything, want to discuss it further, then you can contact us on. Can you contact us there? I've got to put my own email address up. I'll put my own email address up. I'll sell myself. Yeah. Yeah. Thanks, guys. Thanks for attending.
Cool.
Should we stay on?
Yeah, can do.
What do we think? Do you know what? I couldn't see. I need a bit more. I couldn't see the Slido. I don't know how to do that. Do you need to have it on a? Do you need to go to the Slido site? Can't you see?
You need to go to the Slido site and another code in.
I thought that having it integrated into slides, that there would be some way of seeing it through that, but I don't think that.
No.
So I need to have that. But I'm quite happy, Rob, for you to do the questions like that. That'd be a good format.
Yeah, that's a good idea. We make sure we
plan. Yeah, very, very quickly, if there are any, just filter them a little bit. Don't just go from top to bottom and ask all the questions.
To be fair, we were scrapping for questions.
Yeah. I just mean,
let's put some more in there just in case.
How the first question was, how does shift left enable CI/CD? And I was like, well, I think I kind of answered that.
Yeah. I guess my other thing, I don't know if are we allowed to mention company names?
Yeah, I thought that. Probably not. Don't mention Princex. Just say like I did on a recent project I worked on. Yeah.
Right. I'll edit that slide then. That's got the name of the company on it as well. I'll filter that all out. I cut out all of the names and emails, but I didn't do the company. I thought that'd be all right.
What's Rich Pugmy saying here? Close your downloads or leak some dude's name.
You have this SCV at the bottom.
Where?
With the yeah, you'll be all right there.
So just that is that all he's talking about? Just that, yeah. Okay. What else? I think maybe some of your slides, Rob, you might just be getting a little bit bogged down in detail on a couple of them. There's a lot of information you're giving out for one slide. I'm not saying any of it's not relevant. I'm just wondering what do you think, Joe?
This is my concern with the full entire Prezi, to be perfectly honest.
We've got Jake online. Should we let him talk? Let's let Jake talk.
If he's around.
Yeah. Jake?
He might have just gone off for lunch.
Yeah, he might have done. There, Jake?
It might be worth grabbing some of Jake's time and saying because he's already done one.
Yeah.
He's put his hand
up. Yeah.
Should we promote him to a panelist?
I thought you did that.
Yeah. No, I just allowed him to speak. I promoted him to. There he is.
There he is.
Can you hear me now?
Yeah, I can hear you now. Yeah.
Okay. What was your question?
Well, I'll tell you what. Just give us some feedback.
I thought it was pretty good. You need to be careful with that last question on TDD.
Yeah.
Because the way you answered it, Rob, was
I did
for the tester, but TDD is really around unit testing.
Yeah.
Right. Okay. I genuinely didn't know.
Yeah. But yeah, I think Richard's right. There was probably a little bit too much detail in places.
Yeah.
And I think you covered a lot of the stuff multiple times as well, as we were talking about stages and things like that. So I don't know whether you just want to sort of keep it to like one explanation of the pipelines. Because it felt a bit like you covered it multiple times. And you can refer back to it, and you did that a few times as well, because we were talking about adding security tests and how that can go back in the pipeline. I missed the first like 7 minutes, so I didn't see what Richard did at the beginning.
Oh, that was the best
bit.
Was that the best
bit? I know.
Yeah. Okay.
Yeah, it seemed pretty good. It's all valuable stuff. The shift left, and I like your attack on developers, Rich. I'm sure I'll get a few scowls.
Yeah. Yes, of course. I've worked with a lot of them, Jake.
I think he's opening the actual one. He'll get a cheer on that, won't you?
Yeah. Yeah. Hopefully, yeah. Room full of testers. Yay!
Yeah, I mean, all the shift left stuff is stuff that I've advocated for ages anyway, and I was all for it on the RPMI project, trying to help get that set up and everything, which was quite difficult in the beginning.
Yeah.
But yeah, I think it's all good stuff.
Still difficult now, Jake.
Is it still difficult now?
Yeah.
Have we not done it? Is it not all just running smoothly at this point?
Well, there's always little issues, isn't there? Yeah.
There is. Yeah, I don't know if I have much more feedback. Yeah, well, I was a bit concerned around mentioning Print 6 as well, so you probably don't want to do that.
Yeah, I wasn't sure. I wasn't sure if I cut out names from the email slide, but I didn't do the company because I wasn't sure what the rules were around that. So I can just cut those out as well.
Right.
Yeah, because if anyone from one of the clients is watching, then you just need to be careful.
Yeah, it's like because it's open to like and digital and loads of people, isn't it? Anyone could join.
Yeah.
So.
Okay.
The whole stuff around showing the attributes on the test is really good. That was a really good bit. I like that.
Yeah. Yeah. Okay. How many people did we have on in the end? That's the other thing I couldn't see.
16.
16, right. And it
excluding us. Yeah. So.
Right. Okay. All right. Not too bad, I suppose.
I didn't notice that download folder or whatever was in there.
Right. Okay.
It's because the reason why I didn't see it at first was because with Zoom, if you're highlighting over a certain thing, it covers the bottom part of the screen. So I didn't see it until quite far in because I moved my mouse and then it suddenly appeared.
I'm confused. Where is this?
It's when it was sharing the screen.
Yeah, I had a CV open at the bottom, sort of thing, and it just on me. Right. Well, it's tomorrow. I don't think we want to make massive changes. I suppose, Rob, if you just have a look at your slides and just maybe, I don't know, just try and cut it down a little bit.
Unless you're doing a demo, you probably don't need to go into so much detail.
Yeah.
Are you doing a demo or not?
We originally were going to do like a video of it, but not anymore.
Yeah, I don't think you need to. Yeah.
Okay.
No, it's fine. All right, cheers, Jake. That's good.
All right, thanks, Jake.
Yeah.
All right.
I know the one slide I want to cut anyway.
Cool.
But it might mean.
Should we do it together?
Yeah.
So that's
I'm gonna have to jump off because there's a prod issue on RPMI and they're all jumped on another Zoom link. So I'll catch up with you both after that.
See you later, guys. I'm going
to
see
you in a bit.
Right, see you guys. Bye
bye. So we've done that. That's all. So you start about here, don't you? Okay.
Yeah. So I've got 5 minutes before my next meeting, but
continue. Yeah.
It's just that slide where it goes into the detail of that image, the stages and stuff. You know, the not that one, but the
this one. Is it that one?
I'm
not sharing, am I?
No. This one, that one. No, it's your red.
This one.
This one, yeah.
Right. Well, I'll let you go in and delete that. I agree. I think as you're going, I think we can cut that one out. Yeah.
It does make it. It does. It is a lot to talk about. So it is. Yeah.
Oh, maybe you leave it in, but you don't go into the detail that you did. You just say, okay, this is just an example of, just do like one line and sort of thing.
I was like not sure how much detail to go into these slides anyway. So it's good we got that feedback anyway.
Yeah.
I mean, it might make it a little bit shorter, but I think that's fine.
Yeah, I think that's fine. Yeah. Okay. Right. Cool. Well done.
All right.
All right. Speak to you
Cheers,
later.
Rich.
All right.
Cheers, bye.
Bye.